Hello, my name is Paul Newman and I'm the founder and CTO of Oxbotica, a software-based autonomy company here in the United Kingdom. Oxbotica have a fantastic vision. That is to change the way that people and goods move. And we're going to do that by making and writing and supplying software that allows vehicles of any form, of any type, used by any industry to move goods, to move people by writing that software. Oxbotica are privileged to work with an extraordinary array of customers and partners in the industries that we have selected to intersect first. So going from miners in Canada, where we're changing the footprint of mining, through to last mile delivery with Ocado, through to shuttles and industrial environments with our partner ZF, through to energy management of wind farms and solar farms, and perhaps delivery with BP as well. And a list that's as long as my arm of other partners, but those are anchor customers that we have and partners. In May this year, working with Applied EV and also every regulator, stakeholder, view former, policymaker in the UK, we invited them to come in and say, look, we are going to put on public accessible roads the first autonomous vehicle that has no human in it at all. In fact, you couldn't have put a human on it because it had no seat. There was nothing. There's no steering wheel. There's no control surface. It's an autonomous vehicle. The interesting thing about doing that, working with Applied EV there, is all the stakeholders that are needed to do that. We wanted to shine every spotlight we could think on the safety case, the assurance case for doing this, because it is so important that we bring the public and stakeholders with us as we do this. And Applied EV are also then a supplier for the vehicles for some of our commercial partners as well, which is great. So we have partners that are vehicle providers, we have partners that are sensor providers, we have people that we work on some of the software, for example, fleet management suites with our partners Wenco, who are, manage mines, and our autonomy system can interface to them, through to sensor manufacturers, and then through to what we call FOOs, which are fleet owner operators. So those are the people that need autonomy because autonomy is going to upend and transform those industries. Because I tell you this, we've still stuck with one human per vehicle in the vehicle. But worse than that, the person that's operating responsible for the vehicle has to be in the vehicle. That hasn't changed since horses pulled carts or ponies or other animals of your choice. But if you can change that and you can say you could have one human for N vehicles, and those vehicles do not have to be co-located with the operator, then everything's up for grabs. We'll change the shape of the vehicles, we'll change how those vehicles are made, we'll change the safety of those vehicles, we'll change the energy footprint of those vehicles. Let's talk about Metadriver and what the ideas there are and why we think it's so powerful. So let me start with what an obviously stupid thing to do is. An obviously stupid thing to do is to drive around for millions of miles and then go, ta-da, I've proven it's safe. I don't think anyone really believes that's useful now, right? I don't think anyone really believes that you could say anything useful, really powerful about those miles. Like, well, which miles? Where? Under what conditions? Did you really discover those corner cases? And so most good businesses are now saying, well, obviously, well-designed simulation of some sort, doing things in the metaverse, that seems to be really smart because, well, for one thing, I could have 1 million vehicles, I could do 1 million miles an hour if I want to do, or 10 million. That scaling's arbitrary, right? Yeah. But it's still a little bit meh, isn't it? Because, well, which simulated miles? So the worst thing you could possibly imagine is then you waste humans by sitting and they start scripting scenarios. I'll do this scenario. Now, you might want some of those because you might want some canonical scenarios, like, let me just check you've done T-junctions, or let me just check in this mine or in this industrial setting you can understand where people appear from. Sure, you might do some canonical ones. But why are we really trying to do this testing is really because we want to find those crazy hard corner cases. We want to say, have I really done coverage of all the cases that I'm concerned about, but have I really dug into the corner cases? Corner cases for what? What actually do you mean by corner cases? What you actually mean is corner cases for the software under test as well as the scenario. So we actually want to start thinking about a tuple. We want to think about the software under test, the vehicle it's going to run on, and the place it's going to work in as well. Because maybe because there's something interesting about North Berlin, perhaps, about there's a certain junction with certain lighting conditions after certain weathers, in the certain traffic conditions, that actually might make that a lot harder for your particular bit of software. What Metadriver does is use machine learning we have a generating AI that generates the scripts of the simulation. So that's better. So that's better than having humans wasting their time typing and going, look, I've made a scenario. Instead, let's teach an AI to generate those scripts that run up the scenarios that become part of the testing framework. And in fact, those scripts could be informed by the actual place that you're operating in. So that seems to make a sense. Still haven't answered the question about, yeah, but which scenarios? I think the way to do that is to think about the best teachers you ever had. The best teacher you ever had would ask you a question and you might get it 70% right. And the great teacher then goes, I'll ask you another question. It's something to do with that 30% that was wrong. And after about 3 questions, you're like, yeah, I don't know. And so that's made the maximum teaching opportunity at that point. It's being discovered by interaction with the candidate under test, you being taught by the teacher, ends up with, okay, I found a place that actually you're flawed. But you were involved in that. So there was sort of like a challenge response. And so using reinforcement learning, we're able to put the software in the loop that we're testing, informed by the place that we're operating, using reinforcement learning to then come up with the most challenging scenarios for that place and for that release of software. And we're doing this tens of thousands times faster. It will be faster than that when we start to scale, than you would do if you were just driving around. So it's really focused in what it produces and the questions it asks. And that can also be used then to verify and validate operation online. I sometimes get asked, what makes autonomous vehicles so important? And it's a question that makes my soul sore, actually, because I think it's a transformative technology. Think about how we're trapped by how vehicles operate at the moment, and then the consequences of being trapped with those sort of designs. So 1 human in the vehicle per vehicle. How much of that vehicle design and how much of its form factor, how much of its energy use is there because you want to have that human operator in the vehicle? What if you could have that operator anywhere in the world for any number of vehicles, switching in when they need help? Absolutely extraordinary in its transformation. So what this allows you to do is say, actually, I can reinvent my OpEx and my CapEx model for industry. So maybe airports are run differently. I know ports will be run differently. I know mines will be run differently. I know our cities will be run differently because instead of having single occupancy vehicles driving around, we may have bus services that are autonomous shuttles that aren't the size that carrying 60 people. They might carry 16 people because the OpEx CapEx has completely changed. Every single industry that we interact with, by providing a platform for a different way to operate those vehicles, are seeing CO2 reductions, changing in OpEx CapEx, changing the skills that are needed. There's a leveling up to be done here. You don't have to be in the place where the vehicles are moving. And then new industries will spring up because, well, vehicles don't need to be so complex. They can be entirely different than they are at the moment. Different form factor, low energy. They can be cheaper, they can be more specific. We're not having to build the generalist vehicle like the white van that can go 70 miles an hour and 5 miles an hour in a city. It's completely different. The internal combustion engine was transformative about what vehicles can do. The same is going to be true of software that allows these vehicles to be released from the tyranny of one operator and the operator having to be in the vehicle. And I've never met an industry that isn't going to be turned upside down in its ability to innovate if it gets freed from, frankly, where we got trapped with horses pulling traps.